Okay, so brought my document camera here. Let's see if I'm able to enlighten you now with the uh, one side or two side, right? So let's say, imagine that I have my normal distribution here, okay? And I want to know if it's a one tail or a two tail t-test, right? So let's say that first we're going to do one tail t-test, right? So this is one tail. And I have two examples. Basically, this is a one tail, and this, oh, I think it's easier to like, is a one tail as well, right? So basically, what you want to say here is you're testing if a known value is, say this is the mean, right? It's going to be here or not, or in this case, it's going to be here or not, right? So in this case, my alternative hypothesis is that mu is equal, let's say, let's take a value of 40, right? So mu equals to 40, and my alternative hypothesis is that mu is going to be greater than 40. Okay? So whenever I test if it's greater than, right, that's what I'm testing here, greater. I'm doing a one-tailed t-test because I want to know if 40, where is 40, right? Is 40 here or is 40 here? If 40 is here or more, let's see, if it's here or more, I can reject the null hypothesis that mu is equal to 40. If 40 is here to the left, I cannot reject the null. This cannot reject, okay? Sorry about the handwriting. So basically that's what you're testing, right? And this is, if you want to do a 95% confidence level, this means 5% of your distribution, right? So what you do is you calculate the distance between x bar, which is the mean of the sample, and 40, and you find out if 40 is here or if it is here. If it is here, you reject. If it's here, you don't reject. The same thing here, right? This is one tail. So the second one will be the null. Mu is equal to 40, so the same thing. But our alternative, it's that mu is lower than 40. So let's say less than. So the same thing here. You have an x bar, you have a 5% in this side, and if 40 is here or less, you reject. If 40 is here or more, you don't reject. Why is that? Well, because if 40 is here, there is a less than 5% chance of 40 being the mean of that sample, actually. If 40 is anywhere here, there is more than 5% chance of 40 being the mean of that population, right? And we know that because we know the number of standard deviations here, and we're comparing that to a normal curve distribution as we did before, right? Now, this is one tail t-test, right? On a two-tailed t-test, this one was pretty, right? Nah, that's not weird. That's weird. That's the x bar again, but then I'm looking at this side and this side at the same time, right? So because of that, this is 2.5% and this is 2.5%. So it's still 95 confidence level, but the values are different. In this case, my alternative is mu equals 40. Oh, sorry. My null is mu equals 40. My alternative is mu different than 40. Okay? And that's a two-tailed test. So you can see that the critical values for them, which is here, here, or here, or here, are different depending if I'm doing one tail or a two-tail test. Okay? Does that make sense? Does that clear things up? So if 40 is here or here, so less than or more than those values, I can reject. If 40 is between those values, I don't reject. I don't have space. Don't reject. It's don't reject. Okay? Does that make sense? Let's go to the next one.